welcome back to the stream. Yesterday we took a look at Odin, a first look, and looked at the overview page, read through the page and looked at the features, looked at what Odin is, and implemented a very simple program that's just sorting an array. Today we want to take it a step further, and we want to build something bigger with it. Get some experience, get a feel for the language, and see how it goes. We will not build a game. Everyone on the internet seems to assume that Odin is a game programming language. I think there's more to a programming language than just building games with it. If you can build a game, you can build a lot of things. So we are gonna build a very basic HTTP server with it. I have built one very crappy version in C, and maybe we can see how we can improve it with the language and the features that it offers, and see how it goes. Okay, so let's switch scenes. And maybe it's a good idea to open Excalibur to get the fundamental concept. So what we want is something that can just serve static pages. So that's probably the easiest thing to do. So we have, how do you again do this? Was it, escape. Now, how do you get it back? How do you get that back? I don't know. How do you get that palette back? I mean, it doesn't, no. There was some way you can get rid of this. But okay, doesn't matter. What is it, F11, F10? I don't know. Okay, doesn't matter. So we have one server socket. Okay. We have one server socket. Server socket. And this thing can accept we have to look at this. And this is probably shared across threads. So we want a multi-threaded server. This can accept incoming connections. And it obviously creates some sockets here. So for each connection, we create this client socket. Client. Just call it client socket or client specific socket. And with all of these sockets, and all these sockets represent a current connection. So this is a connection. Over TCP. And clients can send something to our server using that socket that was associated with them. And we read from that socket. So we read from the socket and we try to parse HTTP messages from it. So we have incoming HTTP messages or requests. Request. And we respond with an HTTP response. And obviously this is multi-threaded. So each socket is associated with a thread. We see how we do that if we accept on the server socket on a single thread, or if we call accept on the individual threads. So this is on a thread, this is on a thread. There can be multiple, so we want to support multiple client connections, client sockets on a thread. So we need something like ePOL on Linux or KQ on Mac or BSD. So some event polling mechanism for asynchronous connections. One second. And yeah, okay. And what we want to serve is, so we have some directory, some, I don't know, static directory with some files like index.html. Index.html and whatever about .html and so on. And on server startup, we look at this directory. We read in these files here into a file cache. That is basically a map of the name to the file content. Yeah. And maybe we want to support templates at some point. So we'd have to look at the syntax for that. Okay. I mean, at the moment we are on macOS. So I don't know if there's an abstraction layer over this ePOL mechanism in Odin, or if we have to implement that. Yeah. And basically, I mean, I want to have it on Linux at some point. We're gonna start out on Mac OS. I mean, the biggest difference will be this event polling KQ ePOL thing. But we might also want to use features of Linux specific features like IO, urang in the future. But I'm not sure. So, and also I'm not sure how we structure the code. I mean, if we have some platform, if we isolate our platform specific code from the platform, so platform specific and platform dependent, or my goodness, platform dependent code. I don't know if we do that. Also, what I saw was this project that already did an HTTP. Oh, look at this. And Linux. Oh, Uring, they have something for that. Okay, we will not look at this because at the moment we are on Mac OS. But okay, they did all the porting of the. Yeah, this is also something. I mean, if you're in C, you can just link against this code that is already written in C. But when you are in Odin, you have to, because of the calling conventions and stuff, you have to write the bindings, which may be annoying. But I also saw that there's something like bindgen for Odin. Yeah, from Carl Zelinsky. I don't know how good it works. But we'll see. Okay, but that's the idea. So write a basic HTTP server that is multi-threaded, that can serve some static files from static folder, and use epoll, use KQ. I don't know if there is Odin epoll. Odin lang syslinux, yeah. Core syslinux. Is there something like IO? Epoll create. Epoll create. Okay, yeah, epoll is Linux specific, so we have to isolate that, unfortunately. But that's okay. So let's get started. And yeah, what's the name of the project? I mean, this is already called Odin HTTP, so I don't want to call it like that. What's a good name? What is a good name? I don't know. What is a good name? What is a good name? What is a good name? Oh, naming things. The two hardest things in programming, or something like that. Maker. Some analogies. I mean, HTTP server. A little bit boring. HTTP. Odin. So Odin HTTP is what they called it. HTTP Odin. Also very boring, right? HTTP. So I already have an HTTP server. Good. I mean, we have to make a decision where do we start the code in platform specific land, or do we start the code, have the main function in platform dependent land? It's kind of the question. It really depends on how much Odin already abstracts away with the thread creation and stuff. We could start in platform. Oh man, platform specific and platform dependent. That's platform. Let's call it agnostic. That's kind of the same thing, dependent and specific. I believe we want to start. Let's try and start with platform in platform specific land because we're on macOS right now. So should we have a folder structure? I don't know. macOS, HTTP, macOS, or HTTP, macOS, Odin? Is that something? Should we separate folders or something? I don't know. Should we have a source folder? How did they do it? Yeah, we could look at their project and how they structured it. So they have something like that. Besides SSL. Yeah, I guess we just put it in one folder. And also platform specific, platform agnostic things. How do we do the SSL part? How do we do SSL? Should this get its own file? Also, how do you do that in Odin? You just compile a file? How do you compile this? How do you compile this? How many binaries are created? I mean, it probably has just a single main, and it switches on the architecture, right? I have to go pee. 1 second. I mean, I want to set this up in a way so that I can extend this to Linux with epoll. That's probably the biggest difference. But also, how do we do the SSL part? How do we do the SSL part? That's kind of the question. And by I don't know, probably here's a switch on which platform we are. Is it? Can we look at maybe Darwin? Pool and bio. It should be here. The main IO type that holds the platform dependent typo. Yeah, probably the reading of the socket is all probably the reading of the socket is the only thing that's platform dependent. Or is it? It's also reading the file, isn't it? That's already abstracted away, I guess. I wonder where the switch is. So can we search for .darwin? The code. Oh my goodness. Okay. Come on, let's clone this. So git clone. Oh, cd Odin HTTP. Okay, let's is ripgrep here? Yeah, ripgrep, and then .darwin. It's an open SSL server.odin. Server ops in it. Odin OS. Okay. There are a lot of switches in these files, which I don't like. It shouldn't be that way. Listen, serve, wait group. I mean, when we use SSL, we don't, at the moment we probably shall not use SSL. Where's our macOS? Odin, HTTP, macOS, or Darwin. So used to typing. So let's just start with this. You can refactor this later. Okay, now we have to look at how we set up socket. So should we have the main function in the platform specific code or the platform agnostic code, and call into the platform specific code when needed? That's kind of the question, right? But let's just start here. So maybe you have something like setup socket. And probably this returns an int. And okay, how do we set up, man, please switch. How do we set up a socket in Odin? So in C, you would open something, or is it socket? I believe it would be socket for Linux. Then you have to bind, listen, accept, right? That's kind of the order. So let's see what Odin has to offer when it comes to sockets. Oh man. Where's the search bar? Here. Socket. Socket procedure. So this exists. The question is, what is the package? I cannot see. This is in Linux. That's kind of annoying. Why is it only in Linux? Courses. Is there maybe an IO or something? Net? Common. Socket? Any socket to socket. Okay. Make unbound. There's a create socket. A family and a protocol. Create socket. Let's see, where's this defined? Let's look at create socket. Oh no, we don't want to. Oh, okay, I suppose the problem is that we searched in this. So socket, socket, Unix socket, net create socket. Okay, so this looks promising. So we need an address family and a So create, this is also something we can just call, this is platform agnostic. But whatever. So maybe we create a socket. Create socket calls create socket. That's probably not possible, but this was in .corenet, right? Corenet net.create socket. And it gets an address family. Okay, so this is .ip4, and it also gets a socket protocol, TCP, okay, and what does it return? And any socket and create socket error. What is an any socket? TCP socket. Oh, how do these things work? I mean, usually we have to bind and also listen. We didn't specify any and is there an example? And bio open socket protocol family. This is an IO. So there's also an open socket. Open socket, open and listen, open socket. Yeah, then you have to bind, then you have to and listen. Okay, so there's also an open socket. I wonder what create socket, what difference is between create socket and open socket. So create socket and open socket. Open socket. I wonder if that's not even in here. Is there a bind? Oh god. Let's search in net. Is there net? Net.bind. Yeah, there is a net.bind. Net.open socket. Okay, open socket is not a thing anymore. Bind. This takes an any socket. Okay. And an endpoint. Okay, so net.bind. I mean, theoretically, this is not platform specific. Where's net.bind? Okay, net.bind. And this gets an endpoint, an address, and a port. Okay. Do we have to, I can see you have to H to network, host to network, convert this, because network is big endian and host probably little endian orm. Okay, also we have to check the error. If error not equal nil. How do you panic? Is there a panic? Let's look at this. Return. Net error network. This seems like this is an older version, right? Okay, let's call this endpoint. How do you create a struct? Like this? Address, address. IP4 address. Oh, how do you, oh God, how do you do enums, unions again? How do you do unions? I believe you would have to switch on them, right? Where's the overview? Where is the overview again? We need that. Oh yeah, here. And search for union. How do you create the union? Okay. Okay, IP4 address. This is just a U8 and a U8 array. Okay, how do you create this? Union. How do you create a union? Value. This is based on the type, but type assert that v is a string and panic otherwise. Okay. Socket. TCP. I want TCP socket. Is that right? Oops. Okay, TCP open socket. Yeah, this is what we want. We probably also, yeah, this is the exact same thing. The problem probably is that we cannot share this, right? Net.tcp socket. An endpoint has an address. So how do you initialize structs again? I forgot. Struct. How do you initialize a struct? Okay, I see. So it's net dot I wonder if you can even do that. So this is a net.endpoint, and this is a net.ip4 address. Right, and then we also need something else, which was the, so this is a distinct, okay, so now I don't really know if this is possible. We'd have to see. Create socket, or maybe init socket, and this returns an error, so a socket or an error. So this is a net.any socket and net. I don't know, what is it, a network error? I don't know what comes out of this. Go back. Net.network error. So that was that. Network interface. No, that's wrong. Bind, right? Net.bind. What does it return? A listen error, a bind error. Okay, I believe we can just panic on this. So it's not really, I don't know. A network error. The question is there some net.network error? Oh, look at this. Yeah, this is probably possible. So we do something like or return. I believe I saw that this is possible. Or return. So the endpoint also needs a port. So the port was port. No, net dot endpoint. This is just an end. Okay, then we just point to 8080. So is that possible? Or return. And net.bind what does net.bind return? I mean, it would be nice to have an LSP right now, because we're not very familiar with the interface. Okay, the next thing would be to listen. Net.listen. Listen TCP. What is this package? Is it the Linux? Hopefully not. Net. It's sort of shitty to see that, to not see where, in which packages is. I mean, if I search for something, it's kind of annoying. Listen. Yeah, what is the package? You could tell me the package here, but they don't. I mean, hello. God, please. I'm trying to switch. Goodness. Okay. So net.bind or return and net.listen. Listen probably takes something as well. Listen TCP interface endpoint. What is the original API for listen, man? The socket and the backlog. Why does it want an endpoint? That doesn't really make sense to me. So what's the listen method? Listen is a proc. Okay, so Where's this underscore list? Listen TCP. I believe listen TCP is not right. So this, okay, this already creates it. Would be nice if there's an example. Is there an example maybe for sockets? Like if we go examples, absolute beginner, slices, WASM, Win32, arena allocator, code generator, CDNet, CDTCP echo server. Oh no. Yeah, this is a directory. Handle message. So they parse listen TCP. Okay. The problem I have with this is that I cannot define the flags, right? When I create a socket, usually when you look at the POSIX API, I think this is just POSIX. Or isn't it? A socket macOS. Yeah, I think this is POSIX. We have a lot of options here, like choosing the protocol, but also was it here? SO reuse. No, this is I was set socket opt, set sock opt, which allows us to set some flags on the socket. For example, that we want to reuse the address so that when we restart a lot of times, we don't have to wait for the socket to become available again. But I don't know how you do that in Odin. I mean, probably you can just do sys whatever Linux. So let's search again. Listen. Yeah, see. Linux sys listen. POSIX listen. Maybe this is what we want to do. POSIX listen. Bind. POSIX bind. Yeah. POSIX set sock opt. And we can try to listen, to use the listen TCP that's built into Odin. But I don't know if this is any good. Let's comment all this out. And we can, this endpoint, of course, we can use that. Listen TCP. So this is net.listen TCP, and I wonder if it sets the socket option. But I believe it doesn't. So listen TCP. Yeah, it just takes that endpoint and returns the TCP socket. Okay, so socket or return. I believe you. So this is completely platform agnostic. But I don't know if this, we might want to set this asynchronous. I mean, we want to maybe set this not blocking. Oh yeah, set blocking. Okay, you can set blocking on the socket. That's nice. Can you also reuse SO reuse adder? Here it is. Net.set. Set option also available. That's nice. One second. I really like the bots in the chat. Great. Okay. With that out of the way, why is this opening Finder? Hell yeah. Okay. So let's see if this works. Let's format.print ln socket. Is that possible? And just use on return? Probably not, but okay, rm this. Odin builds HTTP. Oh yeah, expected package, package HTTP. Network error is not a type. Oh, how do you do that? Or return within procedure with more than one return value. Okay, great. Error handling. Or return operator. Dot none. Is there a none? Okay, if it just returns the error. What? I mean, oh. Error. So we can do this. Socket, right? Like this. And we can just do a normal return. Okay. Error 1. Like that. Undeclared name socket. Come on. Isn't that how you do it? Undeclared name socket. Oh yeah, okay. That's here. Okay, so now our return requires the current process to have at least one return value. Are you even having this? Oh. So if error is not equal nil, this is probably how you do that, right? Or none. And countered error. We have to get used to this. Three. Okay. That shouldn't work. Port 0. Port 0? I mean, what? Port -1? How would that work? Can someone explain this to me? I don't really understand. Okay, error is not equal nil. How do you deal with errors? Error 1 is equal to caller. So dot none is just a shorthand for nil. Caller 2 returns 1, 2, 3. Okay, so network. Let's look at network error again. Okay. Can we create a bind error? Yes. Non-local address. Okay. Okay, so this works. So let's just do it like this. Okay. Okay, so it listens, and we also want to say socket. No. Okay, we did the listen, and we probably also want to accept connections. Accept. Linux accept. Is there a net.accept? Accept TCP. Gets a TCP socket. So let's assume. What does it return again? Listen TCP. Yeah, okay. Okay. Now accept. Let's just try and accept a socket. Accept TCP. Default TCP options. This is just no delay. No delay. What is no delay? TCP options, no delay. Okay, no delay. That require low latency on every packet sent must be run on sockets with TCP no delay enabled. What does that mean? For this to be used effectively, the application must avoid doing small logically related buffer writes. These small writes will make TCP send these multiple buffers as individual packets. Oh. If we write to the socket, it will immediately send it. Okay, so probably we don't want to do that. We can explore that in the future, but not now. Default TCP options. So just forget about it. Default TCP options. That would be kind of good to know. Default TCP options. Odin net TCP no delay default. Oh god, all these indirections. Is no delay true? Okay, forget about it. We just take the standard, and this returns an error. I'm fine. How are you? How's this HTTP server coming along? We just started, and yeah, it's kind of new language. Getting used to the interface, because I mean they abstracted some things, like this listen TCP, which sets up the socket and binds it to this endpoint and port. I don't know if we want to use this abstraction. I mean, it's nice because it's not platform dependent. Yeah, we are at the very beginning and trying to establish the socket and accept a connection. So if error is not equal nil, so we cannot create socket or setup in it. Unable to init socket. Unable to accept on socket. Let's see. Okay. If we accept it, a connection, this should obviously not be like this. But in the long term, but for now, let's just try if we can accept something on the socket and read from, is there a read, receive TCP. Okay, let's try if we can read something from socket. So net.receive. What does accept return? Accept should return. Oh yeah, a client, a source, and an error. So client, source, and error. Does that work? Does it know that this doesn't have to be initialized again? I don't know. So receive on the client socket, maybe format.println the source, got connection. Now let's try to receive something on this buffer. Let's just have a buffer U8. U8. Let's initialize. Okay, let's have a U8 buffer with 2048 bytes and put in the buffer. I wonder if we have to convert this array to slice, but I don't know. Okay, where's the receive thing? Where did the receive thing go? Net.receive. Oh yeah, receive TCP. So bytes read, and an error. Unable to. Yeah, definitely some interesting abstraction and namespace decisions made by the Odin standard. Yeah, that's true. Yeah, you kind of have to get used to it. Beforehand, I was kind of only used to the POSIX API with your standard socket, bind, listen, and accept. It's kind of the same, but I mean, you only have to specify listen here, which is kind of nice. And you can also set the socket options. I always saw that there's a function as well. To receive, to read from socket. Okay, so let's see if this compiles. No, it doesn't. The error messages are kind of, I don't know. Okay, it wants a slice. How do you convert this to a slice? Is it just... trash? Net.receive. Invalid type. How did I name it? I think that's the word you're looking for. Yeah. I don't know. It's okay. Wouldn't say that's trash. Redeclaration of error. So that's kind of annoying. So I defined error before here using this, so I cannot define it again. is there some kind of example for this? Where was it? Overview. It would be nice if you could just shadow this variable, because now I have to kind of do this. TCP socket and source. Most ergonomic and idiomatic Odin code. Yeah. Init error. I don't know. I'm just poking around right now. We can rename it later, but source. What was the source thing again? Type. Accept TCP. An endpoint. Now I can do this. Or what I could also do is rename it to error1. Or can I make the main function return an error? That's kind of the question. I don't know. Then I can use or return, like here. Okay, I don't know. Let's just what did I want it to do? Oh, yeah, this error thing. Let's see if it compiles. Byte. Byte is a different type. Okay, fine. What? Net.receive TCP. No, it wants U8, buffer U8. What? Hello? Isn't that the way you do that? Oh. Right. TCP. Receive TCP. Undeclared name. Great. Net dot. Redeclaration of error. Bytes read. Accept TCP. Assignment count mismatch. What? TCP socket. Source and error. What does using this over the POSIX layer get you? I believe it gets me nothing. I'm just trying to, yeah, I'm just trying to look at what they did as an abstraction. It really gets you nothing, I guess. besides learning this. Yeah, I don't know. You could also use POSIX. I already saw that this is also available with all of this. So the API is exposed as well. Probably that's what they use under the hood. Anyway, so... But fair enough. Okay. Okay, you need that to grant it to the slice. Okay, accept socket. Undeclared name, accept. Oh my goodness. Always forget to do the net. Any socket. Oh. TCP socket. Okay, that builds. Okay, now hangs. Do we have... Oh, I forgot what it was. Is it netcat? Do we have netcat? Yes, I believe they're very well standardized as well. Yeah, you pretty much don't get a lot from it. We can decide to use POSIX. Later on. I'm just trying. Oh yeah, that's true. So they have TCP and UDP, yeah. They don't do it through flags, but through a union, which is weird. Do they have an accept UDP as well? See, they don't even have an accept UDP. It doesn't make me hopeful for... I don't know. I don't know what they did there, but... You would expect to have an accept UDP if you have an accept TCP. I mean... They were probably trying to do something like this here. But it's not there. Yep. Yeah, I agree. I agree. Yeah, I'm trying to get an understanding of the language and what their decisions were. They're kind of also in the language. There were a couple of things that were kind of weird. For example, that you what was kind of weird was that all parameters that are passed to a function. No, it's like this: proc A and B. And like this. And all parameters that you pass to the function are immutable by default. Yeah, that's fair enough. So you can, what I wanted to say is that you can't mutate them here. You have to shadow them. You have to do something like this to be able to mutate them. But shadowing is not possible everywhere else. It's just possible if you want to declare this mutable. It's kind of inconsistent. I don't know how to feel about that. There were a couple of other things that were kind of weird. But okay. And so is there... Oh yeah, okay. Zero... How does netcat again work? Dash I. Interval cannot... Oh my goodness. Yeah. How did this work again? Oh my goodness. Interval port. Localhost. Like that? No, God. Why not curl? Yeah, I want to just... Yeah, curl is also possible. Okay, we got the connection. That worked. Yeah, I just wanted to send some message. How does netcat again work? Netcat. We could also use man and see. Bound if. Is there... Hostname port. Yeah, okay. So and see localhost 8080. Oh, okay, that works. Okay, so let's also print line buffer bytes red. I wonder why they made this an int. I mean, this will never return a negative value. So I don't know, but yeah, I mean, it's int in the POSIX API, I guess. Yeah. Forgot to build it. Oh my goodness. How do you format this as a string? Oh my god. Okay. Yeah, I know, but okay. That makes sense. Yes. It's true. But how do I format this as a string? Oh, print line Odin. Oh, I have no idea how you do that. Ooh. Can you just... Oh, okay, I see. You can just do C-like syntax. And Python syntax, great. So %s, I guess. Does that work? What? Print FLN. Ah, okay. Good. This works. So let's do curl again. Curl. Yeah. Okay. So we get the HTTP request. That's nice. Okay, so the next thing would be to somehow to parse the HTTP message. I believe. So when the thing is, we can also we might have to read multiple times to get the entire HTTP message out. So probably we want something like a make a new file, maybe HTTP. Okay. Yeah, I know. HTTP is 4.6. I know. I know that's kind of shit. Especially to do it in a single pass. Yeah. That's true. That's certainly true. I already did it at some point. So I'm not completely clueless, but it's also some time ago. And it was very shitty, if I remember correctly. It's more... So also we want to do this asynchronously, so the socket should be non-blocking. Yeah. So how do I want to do this? Let's maybe go to the drawing board. Okay, so yeah, non-blocking is not an issue. Yeah. Yeah, we don't have epoll on macOS, but KQ is the equivalent. Yeah, so we have some back buffer that has, I don't know, some max size. And we now read into this buffer. Buffer size. And we need some state, because in HTTP we have to parse the header first to get the entire size of the HTTP message, when I recall correctly. So we need some parser that has a header and also knows whether it has the header or not. And we read, and then we look at if we have the header. If we have the header, we try to parse the rest of the message. If we don't have the header, we try to parse the header, which may or may not work, because not everything is there yet. I think this is how we want to do it. And again, okay, so this is probably something like handle connection. Yeah, the length is only optionally defined, because it's the protocol is so weird. It also depends on the, what was it again? On the, it can be gzipped, I guess. Yeah, we will not implement a complete a spec complete HTTP server. That's something for someone else, but what was it again? RC. I guess, where was it? Request line. Yeah, compression with content length. But content length, what was it again? Where is it? HTTP message body. Yeah, transfer encoding was it. Can I have either transfer encoding or content length? I don't know if the rules and request is signaled by the inclusion of a content length or transfer encoding header field. Included in a request if this position. Yeah, I don't know. Here, message length. So if a transfer encoding header field is present and has any value other than identity, then the transfer length is defined by use of the chunked transfer coding. So there's probably some chunks in the gzip, and based on the chunks in the compressed thing, you can get the length. And if content length is present, its decimal value represents both the entity, yeah, okay, and the transfer length. Yeah, it's kind of scuffed. They could just say, okay, you have to specify a length and whatever. And also that it's all that everything is clear text. Great decision that you need to basically parse a map to get the headers. But okay, you want arbitrary headers. So I don't know. It's kind of scuffed. So this is a TCP socket, right? I don't know what it returns now. Yeah, just a little. It sounds like you had to implement one before. Or you have done it on your own, and I don't know. This is why I wanted to check your stream. Oh man, I don't know if I'm the best reference, to be honest. And I don't know how far we can get today. Yeah, so we probably... No. I want some connection. TCP connection or whatever. So probably this is also not the best idea to check for my implementation because I've never done anything in Odin. A socket connection. Okay, so we have a socket connection, and this connection has a client socket. Probably will also have to import core net. I mean, if we decide to do this in POSIX, we will have to change all of this, but whatever. Problems for future me. Okay. Oh, you have your own Git server? That's kind of nice. Files. Cool, I will look at that. That's nice. I will look at that. And now Viking. Shit, I already looked at it. Great. Okay. Good. I've already forgot how you do this stuff in Odin. Struct. How do you declare struct? Oh no. Struct with comma. Okay. So client socket and probably some parser. Oh, they do it like this, right? Parser. Parser. And it probably also has this buffer. And you did it completely in C. That's kind of nice. Not even C++. So, bare bones, right? Okay. So, at the moment we... okay, I don't know. Just try to... maybe this should be a pointer. I guess this is the way you do it. We try to receive on the client socket. No, it was receive TCP, right? And into the buffer. And this returns bytes red and some error. I mean, we could, no. Okay, so the first thing we have to look at is obviously the header. Should the parser have the buffer? I don't know. Okay, so header. I think they have this thing called a maybe. Maybe. What was that again? Is it just nil or maybe T is a unit which either returns a type T or nil? Okay. Often see as option. Okay, maybe HTTP header. So an HTTP header has a request method. I don't know if we should do that right now. Should this be a pointer or not? I don't know. I don't believe. I mean, it has to be a pointer, right? Does it have to be a pointer? we can just yeah, either we do this or he has header bool. I don't know. Maybe try this maybe thing. I don't know. Okay, it has a header and it has a body. I don't know if the body is just a U8 array and or a pointer. Probably is. We also need a header map. Or how's that called? Header. Where is it? Is this the right RC is the question. Header. HTTP headers. Message headers. Field name. How do they call this? Yeah. Doesn't really matter. So header map, whatever. HTTP header map. We also have an HTTP header map. I don't know, maybe you could do something like this as well, right? A map, string, int, means a string and a string, right? I don't know. Okay. Oh no, not the parser has this header map. This has an HTTP header and what am I doing? Okay. HTTP header map. String views. String views. Yeah, I don't want to allocate anything. We could also, I mean, this can just be a pointer into this buffer here. I don't know if you can do that. I don't know if string allocates. I believe you can just, you can get a string from this here, from a slice. So we don't have to allocate anything. Just make a pointer into the message buffer. Okay, then we have to somehow check whether the connection yeah, exactly. This is what I'm trying to do. Use just the original buffer. So if connection, should we? I don't know. What? My goodness. I'm trying to switch. Then I want to read the body into the same buffer. Several pooled buffer. Okay. I'm trying to have a buffer for each connection. And use this buffer to, I mean, this is just a pointer to a U8, right? With a size. So a slice is just pointer plus length. And a string is also just a pointer plus length. So this could also be a U, but whatever. But they have this map thing. We probably want to implement our own. Because I believe this is a dynamic thing that allocates all the time. Which is not what we want, but I mean, for a first try, we can use that. We can make it to do use something that we implemented on our own that doesn't allocate. Okay, yeah. Linked list. Also, yeah, it has a built-in arena. So Odin, that's kind of nice. It has an implicit context, and that context is passed to every function. So I don't know what it was, the type, I don't know, context, whatever, and a pointer, and this is done implicitly all the time. And you have a context.allocator, which is kind of your malloc thing. And you have a context.temp allocator, which is an arena allocator. But with, I think it's a growable arena thing. So this is passed around implicitly all the time. You can just use it. You can change that as well to not be implicitly passed in to the functions. But whatever, okay. And what's also nice, we can now, I think we can do this. I tend to use a small per connection arena for allocating these small structures. When the structure references a larger buffer, to avoid wasting space in the linear allocator and doing unnecessary copying between the larger buffer and the smaller sub-allocated allocated buffer. That's just a personal choice. Okay. Yeah, this is what I was trying to do, just allocate all of the thing at startup and then split it up and don't care about what happens. But okay, yeah, you can structure reference. Oh, per connection arena, I see. Yeah, you can do that as well. Yeah, what we don't want to do is allocate all the time. Like when a new connection comes in, allocate thousands of strings. That's of course not what we want to do. My idea was to have a max connections, to just have maximum values for everything and just allocate everything at startup. But we can also have an arena allocator for each connection. That's also something we could do. But I believe we would, I don't know if we have to implement that. Okay, I think we can use this here to pull in all of the symbols. So wait, using. There was somewhere explained using statement. Yeah, I believe that should work. So we you can always sub-allocate the space of each connection for each connection arena out of a larger arena allocated once it's sub. Yes. In fact, I have the same pooled connection design in my code. Yes. Okay. I see. Yeah, we will see. What I wanted to do. Okay, so How do you check whether this maybe is there? Oh man, I am so slow. Dot question mark. Or do we check if it's nil? So if header is equal to nil, okay. Parse header. Yeah, do we do that? Okay, we first have to. Okay, what I have a pool of available connections, yes, and each has an individual arena, but everything is allocated once it's started up. Yeah. Yeah, I think that's a good idea to do that. Yeah, no. It's quite important to think about these things before you start and allocate and free all the time. Yeah, I'll let you work on the code instead of having to read my wall of text. No, that's fine. It's okay. I mean, I'm not expecting to be the most productive when I'm streaming, so that's all right. But I have to go to the toilet. So yeah, now that I think about this, if we probably want an arena per connection, because if it is compressed, we have to allocate memory. In the arena. Yeah, we'll think about it later. I mean, we don't get into compression today. Okay, so let's actually do some work. Okay, so if the header is nil, then we want to parse the header. How do you again parse a header? Where's that? HTTP 1.1 RC. I think there was superseded. Great. I had a nicer web page. Whatever. Okay. HTTP version, blah blah blah. Transfer encodings. HTTP message. Yeah, request line term. Yeah, I think that's what they. No, this is message header. yeah, start line. Request line, status line. I remember it was sort of weird. Oh yeah. Carriage return line feed. The octets menu. Where was that? Start line. Where did I find the start line? Oh my goodness. Get. Nope. I don't. Where is it again? Request line. Request line. So it's method space request URI. This is already, you can just split and turn again. Yeah, I believe that's the first thing we should do is look for carriage return line feed. Carriage return line feed. Now it's request line, carriage return line feed, and then the headers. Carriage return line feed. Yeah, we can just skip if we don't find carriage return line feed. So is there something like a mem? Oh god. Mem. Is there something like that to find memory? Mem. Copy. Intrinsics. We can just mem find mem I guess was in C++, right? Mem. Yes, we want something like that. We can write it on our own. So mem find memory find. Let's do that. So we have some haystack and a needle. And we want to, oh wait, the needle, yeah, it's multiple, right? Now we want a memory find. The haystack is the buffer. Till bytes read. Also, in the parser, do we need to know yeah, here we just read into the buffer. That's not gonna work if we do this multiple times. So we have to start at we need an offset here. So we need to start at, oh, does that work? Buffer at offset. And then we say offset plus equals bytes read. And I'm gonna start at offset. No, that's bad. Cannot do that. We start at offset bytes read. Probably here. And we want to find a carriage return line feed, right? I believe that is how you want to do it. And this, what does it return? I mean, it should return either nil or should return the pointer. You might have to this featured on line feed. Split reads in the worst case. Oh yeah, split across reads. That's right. Yeah, I mean, my idea was to scan for this, and if it's not there, just forget about it. Then go back and use the epoll, and if it's available, do this again. So at that point, we would read into the buffer again. I don't know what this should return, but okay. Yeah, that's just means you need to read a few exabytes each scan. Yeah. We'll see. Okay. For how does that work again? So for C in haystack. No. Okay. For I in 0 dot dot. Okay. Len and len haystack minus len needle. Don't know if this is an off by 1. And then we have to compare these two. Oh, is there a compare? Yeah. Doesn't matter. Okay, then we say haystack I. To guarantee you see the whole unfragmented terminator, i.e. buffer offset minus strlen offset plus bytes read. Oh yeah, you're right. No, if we don't have a header, we just go to offset, right? We scanned it. This was completely wrong. So that should work. Yeah, that was what I did previously was not that right, but I just see if I can parse an entire header, going every time as quadratic. Doing it in chunks means linear. Yeah. I mean, how many times is this called? We could start and find the first. Yeah, what should I start look for the request line first? Headers can usually only be a few KB in size. Yeah, I don't know. I mean, we could start search for the request line first and then have more checks here if we already have the request line, but oh yeah, so what yours okay, I have to understand how you do it. I didn't fully understand it, so okay, so we read starting from offset, and then we look at the last two. So we look at offset -2, for example. Yeah, we can draw it, and then offset plus bytes read. And then find the carriage return line feed, Okay, we can do it. So imagine you get the whole thing in one. Yeah, no, yeah, that's true. If I, okay. Okay, what you were suggesting is get and then HTTP and a URL is coming first. Okay. So index.html, whatever, and HTTP and 1.1 carriage return line feed. Let's zoom out a bit. The next, so headers would follow. So let's say content length. And this is whatever. Is there a space between? Yeah, I don't know, 11. Carriage return, line feed, carriage return, line feed. Okay. So the general theme, so if it comes in at once, we just scan for this. That's true. Okay, what do you say? Now I have to backtrack. Imagine you get everything except the last byte in one receive and the final byte in the second receive. Imagine you get everything except the last byte. Yes. Now you have to backtrack. Yes, that is correct. But how do I know that I only need a line feed? How do I know that I only need a... So when this is coming in, the header is still nil. Header is nil because we didn't really have it yet, right? we would have to change that as well. So we'd have to split up the header into, is there a request line? So then we have this part. Is there a header map? Or am I mistaken? This is the worst case, you know, you only ever have to backtrack. But for nice round numbers, you can pick 4 and nothing changes. It would have to keep more, you'd have to keep more state in the parser, right? To do that. I believe so. Would probably be better. Okay, so we get everything until here. Header is null. Then we read, do another read. Oh shit. But now I have to check the whole thing again, right? Well, the HTTP spec mandates that the HTTP request has a request line ending in character return line feed, 0 more headers, and a final character return line feed. Yes. Okay. Okay. You need no extra state in the parser. You only need your buffer. Yeah, but how do I know that I already encountered these here? Or this? You don't need to. And then I know that yeah. Yeah, you're right. Yes. Okay, I understand. So is it 3? You can also do 0f. Can you also get the length of this? 2x 0f. So this would be 2x 0lf minus 1. And then we cannot increment it here. Read from office. Yeah, okay. Oh, but offset is 0 at the beginning, right? So this would be -4. Okay, so buffer offset, I don't know, the naming is weird. buffer, no offset. So if offset is 0, then offset else offset minus length 2x0f. I got caught on that the first time. Yes. Probably I did as well. Obviously in a different context, but that's always nice if you read from corrupted memory. Yeah. Then you have to go to the debugger. This is also something with Odin. I don't know how good the debugging is with LLDB. So okay. So this thing is this can just be a pointer, right? I don't know how we implement this. Is there something like a compare of two things? 4K in 0 needle. Then we want to continue. I think you can do something like outer here. Oh no, we want to break, right? Break inner. And wouldn't we use the buffer offset? The second time you can still use offset. Yeah, it introduces another branch, right? The first time. Yeah, but how do I know that? I wouldn't reuse the buffer offset the second time. You can simply use offset plus read right directly. Otherwise, you miss out on 4 bytes parsed each receive. What? Okay. Second time, you can simply use offset plus read bytes read. Oh yeah, of course. That's also a bug. Yep, that's true. Thank you. If we are here, we want to return something. And if the client doesn't send a content body, you hang indefinite. Yeah, that's nice. Okay. So we also return nil here. I don't know if that works. So like this. Oh my goodness. Import coordinate expected package. Package HTTP. Expected semicolon. Oh, nice. Okay, you do it differently. You do like this, right? Can't use an if statement in the file scope. What? Oh. Expected. What did you expect? Expected else if offset 0. Ja, moin. If offset is equal to 0. Expected statement. Oh, can't you do that? How do you do this again? My goodness. Ternary. If cont else. Oh, okay, it's like Python. Offset if this else. Also had then else. Great. Length of this. Also. Body, comma missing. 0. What? On nuclear name header. I thought I would have it in here. Do I have to do that? Parser. Huh? I think you have to somehow enable this using feature. Using statement. Man, how did it work? Yeah, I did that, right? I don't know. I saw that in this demo file yesterday. Demo.odin. No, what was it? Examples? Odin. Demo. What? No, demo.odin. Not CD. How do I do this? How do I get to the beginning of the line in Alacrity on macOS? So annoying. Okay, they did this here. Using statement. I believe you have to somehow take this. I don't know. No. Well, now it complains. Yeah, that's whack. I agree. Oh my god. How do you get this? Okay. Undeclared. Shit. Odin, build, help. Less. Yeah, I could do that as well. But I want the compiler to do that for me. There was something in here as well. VET. Using statement. No, that's over, but that's, I guess, just checking, right? VT using statement. Oh my god, so many errors. Undeclared name socket connect. Okay, that's all. Let's try to fix the errors one by one. Socket connect. Okay, now it's better. Now it's just complaining offset. Okay, it works now. But does it work if I comment this out? Using... Okay, you have to do that. I don't even know what VET means. Okay, now we have to convert this to U8. And this has to be also converted to U32. And what did I want to do? So how do we... There was something about conversions. Or maybe I can just do this. U8. Cannot convert this, okay. Well, you should be able to convert this. It's the same thing. There was something with conversions. Converting. Multi-pointers. String. Strings are arbitrary UTF-8 code points with additional semantics compared to unsigned bytes. Yeah, okay. But in theory, you should, I mean, string. Is there a way? There was some, I remember one paragraph. I remember one paragraph that said how you convert all these types. explicit. Untyped types. Nope. String type. C string, string here. So I want from string to X. Transmute. Okay. Can I do that? I believe that doesn't work, right? Yeah, that's constant. Okay, so transmute. Cannot transmute. Oh God. Why? Can I get the pointer? There's no field pointer. Byte by byte. I mean, I could make this U8. Does that work? Can only be used in conjunction with compound literals. Okay, does this work? Let's just check if this works. Yeah, pointer, whatever. Cannot slice array. Let's get rid of this. It's not addressable. Oh, why? Because it doesn't have memory? Yeah, do I have to define it? I mean, this is, okay, this is a literal. This is not something that lives in memory, I guess. So we have to probably do something like this. They probably don't put it in the binary at some place. They just replace it like if you do a pound define. A string may be transmuted. Okay, I guess it works now. Yeah, we can also do it byte by byte. That's true. That would probably also work. How did that go? U8. Hello. Mismatch types. Oh, why is everything an int? Hey, it works. Oh my goodness. I don't know. I don't know why int is why len is an int. I have no idea. Okay. At least it compiles. Broken language? Yeah. I don't know. Okay. Man, okay. Good. Is this memory find even correct? No, it's not. And this is probably very inefficient memory find implementation with all these slices and stuff, but yeah. We'll see. We could also just make this a pointer. I don't know. Okay, if we found this, so header end. So if header end is nil, we haven't found it. And yeah, what do we do? And this is now, how do we structure this? So if it's nil, do we need this if? So if the header is nil, and now we found it, no. So we found the header end. So if header end is not equal nil, something like do receive header end. Well, not header end. The thing is, I don't want to have the while loop in here because I want to have multiple connections per thread. So I just want to exit if we don't find the header. Yeah. So here we try to parse the header, I guess. And yeah. If the header is not nil, okay. So in this case, we want to body parsing, whatever. Okay, parse the header. Parse header. What does this need? Oh man, I have to eat something. Oh, I'm starving. But do we continue? Do we try to parse this thing? Okay. Okay, let's try it. Should we get the connection or just the parser? I guess just the parser. You need to eat, yeah. But I also have to cook something. So this will take a little bit longer. Yeah, that's true. Yeah, okay. Man, we really did nothing. Look at this. Got nothing done. Okay, I guess I'm gonna make myself some food and come back. I'll come back in. Yeah, we have to do some testing here, and we also we have to provide the header and probably you need something testing initially to see if you get the entire header by using netcat and splitting the header manually. Yes, we can. That's a good idea. Yeah, we could try this. So print the buffer to the header end. And like this. Yeah, we can try that. But we have to set up some minimal working thing. Yeah, I don't know how easy it is as well. But we can also use curl. Oh no, we can't use curl because we can't split it. Okay. Yeah. So go into this file. And probably, I mean, the setup code is very messy. We have to clean it up, but we need a socket connection. Do we have to import this? I don't know. And I have no idea what's in there again, so can we just zero initialize this somehow? I think it's zero initialized by default. Okay, let's parser, HTTP parser. Yeah, this is something I like about the language, that it's zero initialized by default. So it doesn't bite you in the ass if you forget to initialize it. And if you do this, it's undefined. This is something I like. Okay, so the parser probably only needs it needs a buffer, right? So we have to allocate this buffer to get this to work. So parser.buffer, and you can do this here. And let's just, whatever. And context.temp allocator. And then do this, and no. So it needs a client socket, and it also needs the parser. And then we can say handle connection just to get it the parser reference to socket connection. Header must be an integer. Oh, I'm stupid. Okay. You'd also just return the index. Is that reasonable? We can also just buffer. How do you do that? Can you just subtract them? Probably can't. Okay, for now, just return the index. Or shall we? Int i32. u32 bool. I don't know. It's stupid, but whatever. So return I and true. Return 0 and false. So this is header end and found. So it found and buffer to header end. Oh no, we search. That doesn't work. Header end, so it's offset plus header end. Probably. God identifier. Like this. Okay, now import core format. What? I have imported that. Cannot assign value I of type int to u32. Great. Okay, parser. Obviously, that doesn't exist because it's an HTTP parser. Okay, so netcat localhost 8080, and then get index.html. Yeah, how do you do? This is not a question. How do I paste carriage return line feed in here? Yeah, HTTP 1.1. And now, yeah, foo's fine. Yeah, that's true. Oh yeah, that's I haven't thought of this. AB. That's good. That's smart. I wouldn't have thought of this. Okay, so nc localhost 8080, and then foo. Why did it print it? Oh, okay. Wait a second. I have a receive here. That won't work. Oh. It closed the connection. Oh yeah, because it read. Oh my goodness. Ah. Why does it say foo AB? What? Foo. Oh. Foo ABA B. Foo ABA. What? That doesn't seem right. Okay, entire buffer. So this is to offset plus bytes read. Yeah, I don't know what receive TCP does. We'd have to look at it. Entire buffer for ABA, that's right. Entire buffer. Oh. The problem is you know what the problem is? If I do enter, it sends a new line. Okay. I think you can do it differently as well. Netcat don't send new line. Oh, you can also, I mean, this is also here, the assist with the, take it with a grain of salt, what they say. Not send a line feed. What the fuck? Use the end of file key. No, that's not what I want to do. Or maybe it works. I don't know. Foo? No. But why did it get here? Did that... I mean, beforehand, if I did netcat this and then foo AB, ABA, it printed entire buffer. Why? Okay, I guess my memory find is wrong. It has to be +1, right? Or is it? I think it has to be +1. No. Is there not mem and some POSIX wrapper? Yeah, I mean, it's usually it's not that hard to implement. Where is the haystack? Yeah, okay. Maybe, yeah. We can look at this. Yeah. Mem. It doesn't seem like it has it. Oh no. Base library. Mem. Oh my god, I have no idea. Yeah. I mean, we should be able to get this right. Sasha's live, yes, you're right. So found should be false. If I foo, just foo. This doesn't make sense. Break inner. It doesn't care. Break inner. Oh my god, that's stupid. Break inner. We'll go here and just return. Great. That will not work. Continue outer. Probably. Yes. That looks right. Now I just have to figure out how I don't send I mean, this +1 was wrong, right? So 5, 7. We can go up to. Oh god, was the +1 right or wrong? God. So if I have A, B, C, D, E, F, G, and I want to find F, G. So this is 1, 2, 3, 4, 5, 6, 7. This is 7 and this is 2. So the difference is 5. And we can go up to 0, 1, 2, 3, 4, 5. So it would be +1, right? But why does it work then? No. Because you check 2 bytes from 5. Oh yeah. So I start. Yeah, but yeah, I do 2. So check 5 and 6. Yeah, but I have to start at index 5, which is the 6th. Or am I mistaken? Zero, 1, 2, 3, 4, 5. Yeah, 5 plus 0 and 5 plus 1. Why do I check 5 plus 0? So end is 5. It's less than 5. It's never equal to 5. It should be only 4, 0 to 4. But shouldn't this then not work? I'm confused, but it works. Does it? Yeah, I don't know as well. I hate these things. No. Why does it find it? So it finds it. So this is 1, 2, 3, 4, 5, 6, 7. Starts at I. Oh my goodness. It's probably because of the new line. Yeah, it's because of the new line. I think it works because of the new line that is sent as well. Because then it scans ahead. So I guess it is +1. Or equals, yeah. Yeah. I guess it has to be +1. Okay. So, but we wanted to test something else, and I don't know how we send something without a new line. Connect. It sends foo new line. This is something we had, right? In case you might want to try this. Yeah, we tried this. Hello. No. Oh yeah, it works. Okay. You can do end of file. Okay, so when we do this, oh, and we send foo ABA end of file B end of file. There it is. Okay, that works. Okay, now, yeah, it looks like. Did you see that here? Oh. Trap. What? Yeah, that's right. What is this? This looks very scuffed. Hä? What was that? Invalid slice index. That seems like some wraparound. Oh my goodness, yes, I hit the bug. Again, if it is less than oh my goodness, U32 length. It's exactly the bug. And I did it again. Yeah. We subtracted. We wrapped around because this was less than 4. Okay, let's change this to character turn line feed, character turn line feed. And I will make something to eat. Okay, thank you. We talked about it and I still did it. Still. Yeah, maybe see you later. But I will turn off the stream now. So, it was cool that you were there in the chat. Thanks for your messages. I will enjoy the food. I just drank coffee this morning and it's time to see some food. Okay, see you.